In this video, we'll be discussing a secrets and key management checklist. Secrets are the keys to your kingdom. Database passwords, API tokens, encryption keys, and certificates that unlock critical systems. Poor secret management is a top cause of cloud breaches because leaked credentials bypass almost every other control. This checklist covers 10 practices for secrets and cryptographic keys on AWS, Azure, Google Cloud, and open source tooling. 1. Never store secrets in code. 2. Use dedicated secret manager. 3. Rotate keys automatically. 4. Use customer managed keys. 5. Enable envelope encryption. 6. Audit all secret access. 7. Set secret expiration. 8. Separate dev prod secrets. 9. Use HSM for root keys. 10. Detect secrets in repos. First, never store secrets in code. Hard coding secrets in source, config, or container images leaves a permanent trail in Git history, image layers, and backups. Deleting the file does not erase history. GitHub reported over 12 million secret leaks in public repos in 2024, and scanners harvest public and private repos. Passwords from years ago could still show up with git log. Docker history and Dive peel intermediate image layers. Treat code as if it may go public. Use multi-stage builds so secrets never land in final layers. Inject secrets at runtime from a secret manager, not build args. AWS Secrets Manager, Azure Key Vault references and CSI drivers, and HashiCorp Vault dynamic short-lived database creds all keep static passwords out of the app tree. CSI drivers, container storage interface drivers, are plugins that enable Kubernetes and other container orchestrators to dynamically provision, attach, and manage storage volumes from various backends in a standardized way. I should mention, this presentation is a condensed version of the complete article on blog.systemsarchitect.io. View the full blog article with more details there. Second, use a dedicated secret manager. Central storage gives encryption at rest, fine-grained access, audit logs, and lifecycle, not just env vars or base64 Kubernetes secrets in etcd. env vars are readable by peer processes. Scattered CI variables and laptops leave no trail. Standardize on one platform org-wide. Multi-cloud teams often pick Vault or Doppler for a single interface. Secrets Manager with KMS and CloudTrail, Key Vault with RBAC and diagnostics, and Google Secret Manager with version secrets and data access audit logs are the cloud-native defaults. Parameter Store Secure String can hold cheaper non-rotating values on AWS. Third, rotate keys automatically. Why rotate keys automatically? Manual rotation is forgotten until an audit. Automatic rotation shrinks the window after a leak. IBM Cost of a Data Breach work has cited roughly 292 days to identify credential compromise. If a password never rotated, that is months of open access. Designed for zero downtime with 2 live credentials during cutover. AWS current and previous staging labels, for example, and test rotation in non-prod first, so you do not lock yourself out. Secrets Manager Lambda templates rotate RDS and friends every 30 to 90 days. Key Vault near expiry events drive functions. Vault dynamic secrets often remove rotation by minting 1-hour credentials per request. Fourth, use customer managed keys. CMKs, customer managed keys, let you set key policy, who can encrypt or decrypt, disable or schedule destroy, and audit use, beyond provider managed keys where the cloud owns the lifecycle. Compliance, finance, and data residency often demand that control so you can make data permanently unreadable by killing the key. Use CMKs for PCI, HIPAA, and GDPR class data. Provider keys elsewhere, grouped by workload or classification, typically 5 to 20 CMKs, not hundreds. KMS annual rotation, Azure disk encryption sets and managed HSM, and Google CMEK with crypto key encryptor decryptor on service agents cover the big three. Fifth, enable envelope encryption. What is envelope encryption? What? A data encryption key encrypts bulk data locally. A key encryption key from KMS wraps only that small DEK. Sending every byte to KMS is slow and, on AWS, limited to about 4 kilobytes per call. Envelope encrypts at CPU speed, then wraps the DEK, a short-lived data encryption key, DEK, encrypts your actual data. Most managed services do this under the hood. For custom crypto, call Generate Data Key or Wrap Key. Discard plain text DEK from memory. Store wrapped DEK with ciphertext. AWS Encryption SDK, Azure Wrap and Unwrap, and Google Tink Streaming AEE8 automate the pattern safely. Sixth, audit all secret access. Log every read, write, rotate, and delete with identity, time, source IP, and secret name. Without that trail, unexpected get secret value traffic goes dark until exfiltration shows up months later. PCI, SOC2, and HIPAA all expect key and secret access logs. Alert on new principals, odd hours, volume spikes, and new IP ranges. Ship logs to a separate account with object lock so an attacker cannot erase the evidence. CloudTrail for Secrets Manager and KMS, Key Vault, Audit Event Diagnostics, and Secret Manager data access logs with log-based alerts cover the stack. Seventh, set secret expiration. Why set an expiration? A max lifetime forces rotation or invalidation, so a 2-year-old leaked password does not still work. Align expiry with rotation plus a short grace. 90 days rotate, 95 expire, so failed rotation alerts before outage. For third-party keys, calendar and manager near expiry alerts at 30, 14, and 7 days. Azure and Google support native expiry and destroy. On AWS, track last rotated date with config or lambda SNS when rotation stalls. Expired key vault secrets return forbidden. Eighth, separate dev and prod secrets. Shared credentials mean a laptop compromise or local SQL injection can hit production. Prefix names like prod/db/password lock prod access to prod service roles, and make CI the only path that deploys code that can read prod secrets. Separate accounts, subscriptions, or projects give the strongest wall. VPC service controls and Key Vault firewalls add network isolation. Ninth, use HSMs for root keys. What do HSMs actually do? Hardware security modules keep master and key encryption keys in FIPS 140-2 Level 3 hardware, so private material never leaves the boundary for memory dumps or hypervisor theft. Regulated industries often require this. Use HSMs for roots, CAs, certificate authorities, and code signing, not every data key, because HSM ops are slower and cost more. Envelope encryption fits. HSM protects the KEK. Software DEKs do bulk work. Cloud HSM or KMS-backed HSMs, Azure Managed HSM, and Google Cloud HSM protection level deliver that top of hierarchy. 10th, detect secrets in repos. Scan pre-commit, on push, and on a schedule, so accidental commits never become long-lived credentials. Block merges on high-confidence hits, AWS keys, service account JY-SON, private keys, and flag fuzzy password patterns for review without drowning the team in noise. GitHub secret scanning with push protection, gitleaks, and TruffleHog verified mode cover history and live credential checks. To wrap up, keep secrets out of code and centralize them so you gain access control, rotation, and audit you cannot get from ENV files alone. Automatic rotation, customer managed keys, and envelope encryption shrink exposure while keeping encryption fast at scale. Access logs, hard expiration, and strict dev versus prod separation detect abuse early and limit blast radius. HSM-backed roots and layered repo scanning protect the top of the key tree and the human mistakes that still leak tokens into Git. Thanks for listening, and put these 10 practices into your next secrets design review. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.